Okay, the next question that we would like to look at is on thermal properties of matter is this question from 2014 paper 2 section A question 5. So let's look at part A and part B first. So the first part asks the energy of a liquid decreases as it turns into solid at melting point. Explain using the ideas of molecules why this decrease occurs. So this question looks simple enough, but actually it is a little bit tricky. The first thing is that you must know what form of energy they are referring to, and the second thing is that it is turning from a liquid to a solid at melting point. So it's kind of weird, because do you turn from a liquid to a solid at melting point? So let's look at this again. So the energy that this question is referring to is the internal energy. So they are saying that why is the internal energy decreasing? Alright. Then the second question is that why do they use the word melting point? But first, let's revisit a very fundamental concept. We need to know that melting point is the same as freezing point. When a substance melts, it melts at the same temperature as it freezes, just like ice. Water freezes at 0 degrees. Ice melts at 0 degrees as well. So this is a question that is just trying to trick people to think that this question is asking about melting, but in actual fact, the liquid is actually freezing. So the question says that the liquid is converting to solid. So the question is actually pointing you to freezing instead of melting. So be careful. So you need to answer using the concept of freezing. So if we know that the question is asking about freezing, let's look at the idea of freezing. When during the process of freezing, energy is released. Okay, condensation and freezing is the process where energy is released, while melting and boiling is the process where energy is absorbed. So freezing, energy is released as strong intermolecular bonds to hold the molecules in fixed positions are formed. So because of that, when energy released, the potential energy component due to the change of state decreases. So if the potential energy component decreases, the internal energy of the molecule also decreases. So that's why the energy decreases. Alright, so this is the answer to the first part. For the second part, it asks that the ice cube tray is filled with 400 grams of water. At 20 degrees, it's placed in the freezer compartment of a refrigerator, and the water becomes ice at 0 degrees. The specific capacity of water is 4.2 joules per gram per degree Celsius, and the specific latent heat of fusion of water is this 330 joules per gram. Calculate the total energy that is removed from the water. So this question is a little bit more challenging, but it's still doable. So first of all, the best way is to either represent it in a graphical way by imagining the water freezing into ice, or you can use a chart or graph to show it. So the initial temperature of the water is at this point at 20 degrees, so it's actually decreased in temperature until a certain point where it starts to freeze. Okay, so this is actually decreasing in temperature of the liquid, while this is the freezing process. So this will be a liquid form, or this will be the mixture of liquid and solid. So for this part, we will be using specific heat capacity, while for this part, we will be using latent heat of fusion. So the total energy required will be the specific capacity component plus the latent heat of fusion component. So the specific heat capacity component is given by mc delta theta, while the latent heat component is given by mLF. So the specific capacity component is 400 times 4.2 times 20, because the change in temperature is 20 degrees, while the mLF is given by 400 times 330, which works out to be 165,600 joules. So that's the answer for part B.